So in this video, we will be concentrating on what is meant by frequency response and how the graphs will look like for a frequency response. All those things we will focus in this particular video. So here is a system block. You take a system, you supply the system at the input with a sinusoidal waveform. Okay, so the input will be a sinusoidal waveform with a particular amplitude and phase. When you supply this particular system with a sinusoidal waveform, you record the output. Okay, so you try to identify what is the relationship between output's magnitude with that of input's magnitude, output's phase with respect to the input's phase. That's what we are going to do in frequency response. So we are going to vary the frequency of this sinusoidal waveform and see what is the relationship between the output's amplitude to that of input's amplitude, output's phase with respect to input's phase. So by definition, it is the magnitude and phase relationship between the sinusoidal input and the steady state output of a system is known as your frequency response. So to obtain frequency response, what's our job? The input's sinusoidal waveform's frequency has to be changed, keeping the amplitude and phase constant. By varying the frequency of the input, you try to note down what is the magnitude and phase of your output. That when you do that, the job is done. That's what this statement says. The frequency response of a system is normally obtained by varying the frequency of the input signal by keeping the magnitude of the input signal at constant value. So what gives you the relationship between the output to that of input? The transfer function. If it is a open loop system, then the open loop transfer function gives you the relationship between output and input. If it is having a feedback, then the closed loop transfer function will give you the relationship between the output and input. So to obtain the frequency response, the first step you do is in the transfer function, you try to apply S is equal to j omega. S should be replaced with j omega. Now the transfer functions, either it is a open loop transfer function or it is a closed loop transfer function. The transfer function now will be in terms of omega, that is a frequency. Once you get the transfer function in terms of j omega, that is you are replacing S with j omega, now the function, the transfer function, open loop or the closed loop transfer function will be in terms of omega. Once the j comes into role, you will have a magnitude and phase. So this g of j omega, now you can you will be able to write it as magnitude separately and phase separately. So since it is j omega, it is a function on j omega, so you will be able to write this g of j omega into magnitude and phase. If it is a closed loop transfer function, let me write the closed loop transfer function by t of j omega. So for this also you will be getting a magnitude and phase. So now you have to take down this magnitude and you have to compute the magnitude for different values of frequencies. And if you are going to plot it between the frequency and magnitude, you will get a frequency response curve, that is for magnitude. And if you are going to compute the phase of the closed loop transfer function for various values of frequencies, and if you are going to plot it between the phase and the frequency, you will get phase plot. That is also a part of frequency response. Actually, frequency response curves you can tell in two types. That is, one is magnitude curve, another one is phase curve. Magnitude versus frequency, another one will be phase versus frequency. So in the next slide, you will see one graph where I'll be able to explain better what is a magnitude graph and a phase graph. Both graphs put together is called as frequency response curve. Here you see is the magnitude versus frequency. Okay, x-axis is frequency and it is drawn between magnitude and frequency. And here you see it is phase and frequency. So there are two curves put together. It's called as frequency response curve of a system. For your information, this is not the only way of drawing frequency response curve. This is one of the ways of drawing frequency response curve. So this better explains what is meant by frequency response. So I have used this. So there are other ways to draw frequency response curves also. This one is the most simplest, that is magnitude versus, that you draw in a semi-log graph sheet, that is magnitude of the transfer function in decibels versus log frequency, log of omega, and phase versus frequency. This graph will give you lot of information. We are going to study something called frequency domain specifications, which we will compute from these frequency response curves. Things like at which frequency maximum magnitude occurs, at which frequency there is a cutoff, that is the gain starts to reduce, at which frequency the phase is at minus 180 degree. All these things will come under frequency domain specifications. So we will first derive the frequency domain specifications, and we will define what is meant by frequency domain specifications, and then we will move on to drawing the frequency response curves and how to obtain frequency domain specifications from frequency response curves. That's of course the main objective of this particular unit. There are certainly many advantages in doing frequency response analysis. One main advantage is for an open loop transfer function, if you're going to draw the frequency response, then you can estimate the relative stability of closed loop system. So there is a connection between open loop transfer functions, frequency response, and relative stability of closed loop system. So that is one good advantage of frequency response analysis. Once you design a system, you can test the system with the available sinusoidal signal generators at your laboratory. So if you're going to design a complicated system, and if you want the transfer function for it, then you can experimentally calculate the frequency response of the system, and then from the frequency response you can obtain the transfer function of it. If you want a closed loop system to perform in a certain manner, then you can adjust the parameters of open loop transfer function easily if you're going to work in frequency domain. If you have designed a system and after designing a system you have obtained the frequency response of it, and if you find that there are some noises, then you go back to the system and you make some parameter changes so that you reduce the noise. And now using a frequency response analysis, you will be able to visualize the effect of noise reducing variations that you have done in the system. So using this frequency response analysis, you can visualize what is the effect of variation in parameters that you have done. So these are all some of the advantages of frequency response analysis. In the next video, we will look into the frequency domain specifications. What are frequency domain specifications and how to derive all these specifications? That will be dealt in the next video.